this is for difference equations, different from differential equation. So there are many terms that are similar between the two of them, but in this difference equation we are using a totally different formula, although the form of the formula is also similar. So this will be very quick. I'm going straight to the general formula for first order linear difference equation. Just like we have the general formula of differential equation, first order differential equation, we also have the general formula for the first order difference equation. So this is how a difference equation looks like. Remember, in differential equation we also have the form of differential equation. In differential equation we are given that, we are told that this is how a differential equation looks like. Once it is differential equation, it's going to be like this. Let me zoom in. So differential equation is always like this: dy dt plus ay equals to b. That's how a differential equation looks like. You see that it is totally different from this, which looks like this. So sometimes you might not be told that this is a differential difference equation. They expect you to know if it is actually a differential difference equation. So you'll be given a difference equation and you'll be asked to find the general formula. You'll be asked to find the general solution of the difference equation. So that is when you now use this general formula. But here we have two general formula, or let me say three. Remember, in differential equation we basically have just two. In fact, we have one. That one is now written in two form. That one, the one that we have in differential equation is this. Just as a reminder, we are told that y of t in differential equation, our general solution formula is given as this, equals to y0 everything in bracket minus b over a Sorry, this is the continuation down here. In the first video you actually see everything there. Sorry, that's not long. So e raised to power minus 80, this continuation of the 8 times e raised to power 80 plus b over a. I remember in differential equation I now said this particular one can also be replaced with just a whenever you are not given y0. So those are the two forms of formula. It's still one, but they are just written in two forms. The same thing applies to this. This is the general formula, but everything here can also be written as a. In case you are not given y0, can also be written as a. So you can have a bt plus a over 1 minus b. But if you are given y0, you just have to use y0 minus a over 1 minus b, bt plus a over 1 minus b. But this is when b is not equal to 1. So far b is equal to 1, we don't want these particular guys to be giving us 1 minus 1 is 0 in the denominator. So if b is equal to 1, we won't be able to use this formula again. So that's why we are now introducing this new formula whenever b is 1. So whenever b is 1, you are just going to use yt is equal to y0 plus 80. So that's just the formula you are using whenever b is 1. Please take note of that. So whenever you see a question, the target is first check, is this b1 or not? So if it is 1, then you are using this shorter formula. If it is not 1, then you are using the long formula. Then if y0 is given, you don't need to use you need to use everything. Like if y0 is not given, you just have to change everything here to a. So that's when that is given. So that's the formula for the general solution. Let me clear everything. So let's take one example, or let's see if we can take two examples. So we have this example here. We are asked to consider the difference equation yt. If you notice, in difference equation the t is always at the base, unlike differential equation that the t is like in brackets. So in difference equation the t is actually in the base. So now another way to know which one is a difference equation or not. So we are told that we should find the general solution of this particular difference equation, this one here. You get to this, and y0 is equal to 5. Now from this particular equation, the first thing to check is that, okay, number one, we are given y0, so we know we are not using a will not be in our answer. So number two is that, what is b? Now our general form that shows us, this is our general form here. Now our general form already shows us how our question will look like. So this is our general form here. So this is our b here. So it simply means our b in this question is -7. But also remember that it can be scattered. So the one that has that y t -1 in the base is actually that particular one that will carry the b. So no matter where it is arranged, if they bring it here as +7 yt -1, you just have to transfer it back to this side so that it will change to -7 yt -1 before you now choose your b. Don't choose your b when it is still at this side. You'll be getting the wrong answer because you'll be using +7 instead of -7. Rather, bring it this way, the way it do look like, then change your b to minus, then it will now be b equals to -7. And the same way, they can actually write that yt is equals to 16 -7 yt -1. So the arrangement should not make you go and choose 16 as your b, thinking that, okay, since it's b that is to come first after the equals to. No, it's actually this yt -1 that make us know that, okay, this is actually b because of this form. So our b here is -7 and our a is 16, while our y0 is 5. So from this formula, just change this y0 to 5. That's how we get this. Just change this a to 16. Just change 1 minus b. Change b to -7. So we have 1 minus -7. So we now have minus times minus plus. That's how we get this plus. Then times b raised to power t. What was our b again? -7 raised to power t. Plus a is what? 16. 1 minus b, which is -7. So we get 1 plus 7 again. So this will now be equals to, by the time you do 16, 1 plus 7 is actually 8. So 16 divided by 8, that's 2. So 5 minus 2 give us this 3 here. That's how we get this 3 here. Then this -7 raised to power t, there's nothing you can do to it, so you leave it this way. So plus this divided by this will also still give us 2. So that's how we get here. So this is actually your final answer. You cannot multiply 3 times -7. No, because of this t here. You must do -7 raised to power t first before you multiply it by 3. So, and there's no way we can do -7 raised to power t if we don't know t. So that's actually where you are going. Everything ends. That's actually your final answer. But you can check if your answer is right. Sometimes you will even be given the question that to check if you have actually done the right thing. So how do we check? to actually check, you have to substitute. You have to assume t is 0 when t is 0, and you have to assume when t is 1. You have to assume that t is 0, and you have to assume that t is 1. So simply from this your answer, when t is 0, what will be your figure? So by the time t is 0, you are going to have 3 raised to power minus 7 raised to power 0. Anything raised to power 0 is 1. So minus 7 raised to power 0 will be 1. So we now have 3 times 1, which is 3, plus 2, which is 5. That's how they get 5 here. Saying that okay, when t is 0, we are going to have 5. But when t is 1, it simply means minus 7 raised to power 1, which will also give minus 7. So minus 7 times 3, that's minus 21. So minus 21 plus 2, that's minus 19. That's how you get this minus 19 here. So when t is 0, we have 5. When t is 1, we have minus 19. So that is the first step whenever you want to check. Now you now come back to your question. This is your question here. This is your question. You now substitute this 5 and minus 19 with, and you substitute this yt and yt minus 1 with 5 and minus 19. But the question is, which one is 5, which one is minus 19? Now y0 and y1, this y0 simply means yt. If this y0 is yt, y1 will simply means yt plus 1, because for you to move from 0 to 1, it simply means you added 1 to 0. So if this y0 is yt, this y1 will be yt plus 1. If this y1 is yt, y0 will be yt minus 1. Yt minus 1. So that's how you are going to get it. Look at this. They do not use t and t plus 1. They can also use t and t plus 1. It does not change your method. But in this, they use t and t minus 1. It simply means our y1 is yt and our y0 is yt minus 1. So replace this yt with your answer here. That's minus 19. Minus 19. Now replace this your yt minus 1 with your answer here. That's minus 5. So what they just want to show you here is that by the time you solve this, it must give you the same thing here. So by the time you multiply minus 7 times minus 5, you are changing everything here like this to minus 5. Minus 7 times minus 5, that's minus 35. So minus 35 plus 16, you see that it will give you minus 19. So the two of them are equal. It simply means your answer is correct. So that's how to check your answer if it is correct. And sometimes, don't say I don't need to check my answer if it's correct. Sometimes they may actually ask that, okay, prove that your answer is correct, or show that your answer is correct. So you have to still know this. So that's actually how to check if you are right. So if you miss any part, just take the video back a little and rewatch it, because we have no time to just go over it again. So that's actually how to look for the general solution of a difference equation. General solution of a difference equation. So let's look at, and this is for first order, let's look at the second order difference equation, which according to the past question is more common, and it's common than this first order. So let's go into that. So here is second order difference equation. Now remember, in first order difference equation, we are given that yt, and then the general how it looks like, the form of a difference equation is always yt equals to b y t minus 1 plus, sorry, everything plus a. That's for the first order. But in the second order, this is how the form looks like now. The form is now yt plus b1 yt minus 1 plus b2 yt minus 2 equals to a. This is how the form of the second order difference equation looks like. Another thing you should notice, something that also happens in differential equation. Remember, I explained that in differential equation, when you are finding the first order, the general solution of the first order, most times they will just ask you to find the general solution directly. So out of the general solution, you can now bring out your YC, which is your complementary solution function, and your particular integral. Complementary function and particular integral. If you have forgotten what that is, quickly run to your video. So, but in the second order differential equation, they won't ask, most times they won't ask for general solution directly. They just ask you to find the complementary function and or particular integral. So if you now want to get your general solution, you have to add these two together, your complementary function and particular integral. The same rule applies here too in the difference equation. Can you see that in the first order difference equation example that we did, they simply asked us to find the general solution. From our general solution, we can actually bring out the complementary function, which is the one at the everything at your left hand side before the plus or minus, then your particular integral, everything at your right hand side. But in second order, just like differential equation 2, most times we ask you for the complementary function and or particular integral. So if they don't ask for the general solution, they expect you to add the two together. So that is what this particular concept is actually talking about, that our YT, our general solution, is actually the addition of your complementary function and your particular integral. So you just add these two together to get your general solution, but mostly they will ask you to find your complementary function separately and your particular integral separately. So if you are given a difference equation like this, how do you look for your complementary function and your particular integral? That is where the question is. So to look for your particular integral, you use this formula. The formula to have similar rule like differential equation. Remember, in differential equation second order, we have like 2-3 formulas whereby we are saying when b is not equals to this, when b is equals to this, you can then use this. So the same thing applies here. So in second order difference equations too, this is actually our formula for finding the particular integral, but this is only when b1 plus b2 is not equals to minus 1, because when b1 plus b2 becomes minus 1, this will be 1 minus 1, which will be 0, and we don't want 0 to be in the denominator. It will not make our answer to make sense. So that is why you are not going to use this formula if b1 plus b2 is equals to minus 1. But if it is not equals to minus 1, you can use this formula. But if it is equals to minus 1, which formula do we use? Then you come down to this. If b1 plus b2 equals minus 1, it simply means you are coming to this. But you can also only use this if b1 plus b2 is equals to minus 1 and b1 is not equals to minus 2. If this b1 is equals to minus 2, it simply means we have 2 minus 2, which is 0, and we don't want the denominator to be 0. So if this b1 equals to minus 2, you have to use this third one. So those are the 3 formulas you have to know for your particular integral of your difference equation. Why for the complementary function? For the complementary function, also similar to that first one, it simply means that we are going to use this particular equation to find our complementary function. a1 r raised to power t, r1 raised to power t plus a2 r2 raised to power t. Now the formula for r1 and r2 is still the same thing as that of the differential equation, but the whole formula is different. In differential equation, this is not how the formula look like, but here in difference equation, this is how the formula looks like. In differential equation, if I can remember, we have a1 e raised power RT, but here can you see that that's not what we are having here? So but in different equations this is what we are having, but the R is still the same thing. We still have the same formula for our R1 and our R2. So that is what you should take note of. That's what you should take note of. So let's get to one example and do that, then we'll move on. So this is an example here. We are going to do example 5 and 6. So in example 5, we are asked to find a particular solution for each of the following equations. So we are given these 3 equations. We are asked to find a particular solution for them. So let me scroll up so that you can see our formula. So we'll just be replacing them. Can we see them together? Let's move this guy up here. It's the one recording our screen, so we can't take it away for now. So let's start with the first one. The first one says that we should find the particular solution for this particular guy. So let's look for our A, our B, our C. Remember the form of A. This is the form of A. This is how a differential equation look like. A difference equation look like. YT. This YT does not have anything before it. Plus B1. So our B1 here is representing minus 10. So our B1 here is minus 10. So plus B2. Our B2 here is plus 16. That's 16. And equals to A. Our A here is 14. Also remember, they can scatter them. So always know that the Y carrying T minus 1 is the one that always have B1. The one carrying T minus 2 always have B2. And why this A is the one that is always standing alone, no Y with it at all. So that's how you know it. Not that you say the first one is B1, no. So the one with T minus 1 is B1, the one with T minus 2 is B2, and the one without YT at all is A. So these are B1, B2, and our A. From here, these are B1, these are B2, these are our A. So from here, these are B1, these are B2, which is 1, nothing here, so it means 1, and these are our A. So let's now go to the solving of the question. So the first question, so we have to find a particular solution. So you have to check if B1 plus B2 is equal to minus 1 or not. So what was our B1? Minus 10. What was our B2? 16. So minus 10 plus 16 is actually 6. So this is not equal to minus 1. So we can use this formula. We are good to go with this formula. And the formula say A over 1 plus B1 plus B2. What was our A? 14. So that's how they get the 14 here. Over 1 minus B1. Now 1 plus B1. So B1 is minus 10. So we change B1 to minus 10. Plus B2. So B2 is 16. We change B2 to 16. So we have 1 minus 10 plus 16. 1 minus 10 is actually minus 9. Minus 9 plus 16 is 7. So we have 14 divided by 7. That's how we get to our 2. So that is done as dusted. As simple as that. So we go to the next one. So from the next one, this is it. These are B1, B2, A. Now let's check. Our B1 plus B2 is Z equals to minus 1 according to what the first formula says. So B1 is actually minus 6. B2 is actually 5. Minus 6 plus 5 is actually minus 1. So we can't use that first formula we just finished using here. Nah, it won't work. So we can't use that. Then we move to the second formula. Let's check if B1 plus B2, if B1 is not equals to minus 2. So b1 is b1 equals to minus 2. This is b1. No, it is minus 6. So we can use this second formula. So replace whatever is here with your question. So a is actually from here. A is 12. So replace a with 12. Okay. Then we have 12 over 2 plus b1. What are b1? b1 is actually minus 6. That's 2 plus minus 6. That gives 2 minus 6. Then you put your t. Please don't forget this t. Then you put your t. So 2 minus 6 is minus 4. 12 divided by minus 4 is actually minus 3. That's how we get minus 3t. You can see that is actually simple. Then the last but not the least is this guy here. So we have yt minus 2yt minus 1 plus yt minus 2 equals to 8. Now let's check if b1 plus b2 is equals to minus 1 first. b1 is minus 2, b2 is 1, invisible 1. So minus 2 plus 1 is minus 1. So we can't use the first formula. Now the second one says b1 must not be equals to minus 2, but you can see here that b1 is equals to minus 2. So we can't use the second formula too. So we are only left with the option of using the third formula. So we are going to use the third formula here. So the third formula, a over 2, what's our a? 8. That's 8 over 2. Then t squared. Then we put our t squared. 8 divided by 2 is 4. 4t squared is our final answer. So that is how to look for the particular integral. Particular integral of a difference equation. So from that same question, they can also ask you to look for the complementary function. The complementary function. That's what we are going to do right here. So to do the complementary function, remember that we are using this formula. Let me write it out. It's actually up. You can check it there. So our complementary function yc is actually a1 r1 raised to power t plus a2 r2 raised to power t. So a1 r1 raised to power t plus a2 r1 raised to power t. That's our formula for complementary function. So and our r is still the same r we use the differential equation. Remember, it looked like what? Quadratic formula. So which is minus b plus or minus square root of, so this minus b is actually minus b1 square root of b1 square minus 4b2 over 2. So please try as much as possible to solve a lot of questions. That's how this formula will think. There are still some formulas that I don't know, so I'm hoping that when I solve more questions I'm going to know them, but because it's not automatic, these formulas they are actually figures, numbers, letters, all of them just modded up together. So your brain cannot just keep storing things like that. That's not what it's meant for. So it will be hard for you to just store those formulas. It's natural. It's not that you are not intelligent, that's why you can't store formula. No, that's entirely not it. It's simply because that's not what your brain is meant for. So that's it. So it's no way your fault. So you have to just, as Avocado will say, force it to balance. This time you have to force it to enter. So by the time you keep solving, you're actually passing a message to your brain. When you keep using that formula, the brain will believe that okay, it's actually seems that you actually need this particular formula, so it's going to move it from your short-term memory to your long-term memory. So it's going to be stored for a longer time. That's how you are going to know it. You just see that without even thinking, if I just write out the formula. So there's no magic in this thing. There's nothing really special in this thing. So it's not too complex for anyone's brain to actually handle. Just follow the rule, do the method, and you're good. So now let's back to our R1 and R2. So R1 and R2, that's what we are looking for here. So minus B1, what's our B1? In this our first question, that's minus 10. So by the time you do minus 10, so see, don't be tired of writing minus twice. Don't be tired of writing it 3 times. Don't be tired of writing it 4 times. Because if you just go and take minus 10 here, you're going to put minus 10 here, your whole answer is now wrong. So you have to write the first minus that is in this formula, then now put its own minus 10. So that will be minus times minus plus 10. That's how they get their plus 10 here. Then your plus or minus square root of B1 square. What are B1? Minus 10 square. Minus 10 square means minus 10 times minus 10. It does not mean minus 10 times 10. No. Minus will come in 2 places. So minus times minus is plus. 10 times 10 is 100. That's how this Mr. 100 is showing up here. Minus 4B2. Minus 4. Then our B2. What are B2? 16. So that's how we get the 16 here. Everything over 2. So by the time you solve 100 minus 4 times 16. 4 times 16 should be 64. Yeah. I think I'm right. 64. Then 100 minus 64 should be 36. So find the square root of 36. That's how they get the 6 here. So we have 10 plus or minus 6 over 2. So that's how we now have 10 plus 6. R1 will be 10 plus 6 over 2. And R2 will be 10 minus 6. 10 minus 6 over 2 AG. So 10 plus 6 is 16. Yeah, 16 over 2. So that's 8. And 10 minus 6 is equals to 4. 4 over 2, that's 2. So that's how we got our R1. I prefer to use my R1 as 8, my R2 as 2. They also do the same thing in other questions. Only this number 1 question, I don't know, maybe it's a mistake, and I don't know, maybe it doesn't matter which one comes first. But since I've seen that all the other questions they bring R1 first and R2 second, only this one, so I just follow the majority in this case. I don't want wahala. So the YC will now be equals to, remember our formula is this: A1 raised to power R1T. Your A1 will not change, so your A1 will still be there. So what is our R1? In this place, the R1 is 2, but when you switch it the way I said, your R1 will be 8. So you can just put your 8 raised to power T plus A2. Then this one will be your 2 raised to power T. As simple as ABC. That's your complementary. So you can do the same for this second question, this third question. Do the same for them. You wind back this particular video to see anywhere you miss. So in a situation where they now ask you to find the general solution, what you are just doing is that you just add this your guy here. This your guy you just got here. So you just add that first one you get here plus 2. Just add it here plus 2. And shikena, that's your general solution. And that's just about everything you basically need to know in difference equation. It's still very much wide, but I believe that all those parts are not made for us, probably in year 4, for those that will do advanced mathematics in the year 4. But I think this is basically everything we need to know in difference equation. I wish you good luck in your exams. So let's stop there.